Hello everyone, my name is John, and today in this video I'm going to be going over the mineral lazulite. So I just wanted to start by showing you a quick web search of the mineral just to give you a general sense of what the mineral looks like. As you can see, you're not really going to find this mineral in any other color except for blue. Any of these other colors that you can see here, like white, is usually just some quartz that's mixed in or some other mineral that has another color. Lazulite is also used as a gem if it's cut, or you can just have it sold as a sample here. As you can see, this one's going for $30. So obviously it's not like a super valuable piece, but for a 37 gram sample, hand sample, this isn't really too bad. So it does have, its worth, and it has an attractive appearance, obviously. So people are, looking around for this kind of stuff, and I think what makes it really stand out is kind of this vibrant blue color. Here's an example of some lazulite that's been cut with different faces. And as you can see, it still has that vibrant blue color, and that's kind of what people are looking for in this kind of mineral. One additional little bit of information that I found interesting was just the influence that lazulite has had on pop culture. Even here in this video game, Warframe, we also have, an item that has this blue color that's lazulite. Just goes to show how influential that color in the mineral can be. Also here we have Sekiro, which is another video game. Just thought that was kind of interesting. Okay, so here's just some general properties for lazulite. So the formula is magnesium, aluminum, we have phosphate, and we have hydroxide. Its color can be described as blue or sky blue and bluish white. So as I said before, you're not really going to find this in any other color, and any other color you find within a sample is likely to be just some other mineral like quartz. Its streak, interestingly enough, is white. So if you scratch it like a piece of chalk on a scratch plate, you're going to get a white color. Its luster is vitreous or subvitreous, resinous or greasy. So that's just to say that it has a little bit of a reflectiveness about it. It's not dull or earthy or anything like that. You could almost consider it like it has a film on it that is a little bit reflective. Its hardness is 5.5 to 6 on Mohs scale, and this just means that it's going to be harder than a copper penny, but at the same time it's going to be softer than something like a steel nail or something like that. Its specific gravity is about 3 down here, and that's just to say that it's going to have a density that's 3 times as dense as water. So if you were to have, a bucket full of water, if you compared that to a bucket full of lazulite, that would be about 3 times as heavy. In North Carolina, we can find this mineral throughout the state. On the site MinDat has a list of the different areas that lazulite has been found. Obviously, this isn't everywhere that lazulite can be found within North Carolina. However, on the MinDat website, this is all the locations that have been documented and confirmed. If we zoom in a little bit, we can find that the closest to the Triangle area, or NC State, would be in Hillsborough at the Occoneechee Mountain State Natural Area. This is a pretty nice area that you can walk around, and there's also, if you zoom in here, you can find that there's a mine here. And obviously in this area, there has been some lazulite found. Lazulite can also be found in Alamance County near Snow Camp at the Holman's Mill Mine, at Randolph County at the Carolina Pyrophyllite Mine and the Staley Mine, and also Moore County at the Glendon Mining District. And then we can move over to the Charlotte area where we can find azulite in Lincoln and Gaston counties. While North Carolina does have a lot of lazulite, This can also be found in other states. So a really good place if you're actually interested in finding yourself a specimen would be Graves Mountain in Lincoln County, Georgia. If you went down there, you can get in for about $15, $20. And on their site here, they also include lazulite as one of the minerals that can be found there. So this is an old mine. You can just go in and find yourself a sample, and it's a really great resource if you're actually interested in finding a personal specimen yourself. If we hop back over to the MnDAT website, we find that the rest of the United States also has some areas where you can find lazulite. So while there is a lot in the Georgia and North Carolina area, you can also find some in California region as well as the New Hampshire region. And then if we zoom out to the rest of the world, you can find some in Canada, and also a really well-known area for lazulite is Austria and also Italy. So if we go in this kind of area, we see that there are a lot of areas that can be found for lazulite. And really almost everywhere in the world you can find it. I'm sure more areas will be added as people find and add this data to the MnDAT website. But you can even look down in Antarctica, you can find a little bit of lazulite. It can be important to know about the associations of lazulite. So in this example here, we have lazulite with quartz. I think this is one of the most common associations for lazulite. And here you can see the quartz here and then the blue lazulite. And then we also have with siderite. So we have the lazulite here, and then this brownish blocky stuff is the siderite. With whiteite, so the whiteite is here, and then the lazulite. And finally we have apatite, which is another mineral that is blue and could be mistaken with lazulite. So I kind of like this photo because it kind of gives you a comparison. In this photo, these darker blue crystals are going to be the lazulite, and then this lighter blue is going to be apatite. Now, the thing is that lazulite can also be a lighter blue, so you can't really, this kind of goes to show that you can't just use color when distinguishing between the different minerals. You're going to also have to look at the hardness and the crystal form and all that for determining which is which. But also keep in mind that both these minerals can be found together. Okay, let's take a look at the morphology for lazulite. So the crystal system for this is going to be monoclinic. And if we take a look at what the definition of monoclinic is, we see that if we throw some axes on this crystal, we're going to see that the angle between A and B and C is going to be 90 degrees, and the angle between C and A is going to be greater than 90 degrees. And also we're going to know that A and B and C, these three axes, are not going to be equal. So let's go back here, put some axes on this, and we see that the axes lengths where they intersect are not equal. And we see that the angle between B and A is 90 degrees, but we see that the angle between A and C is greater than 90 degrees. So that's how we would classify that this crystal is going to be monoclinic. If we look at the morphology at a molecular level, we can compare to this equation up here that I have written for lazulite. And we have magnesium, aluminum, phosphorus or phosphate, and hydroxide. So looking at here, we can see that these red or green balls are going to be the magnesium. We have red is going to be the oxygen. We have orange, which is going to be the phosphorus. And purple is going to be the aluminum. So if we can make out here, we have 1 phosphorus and 4 oxygen, just like in the equation here. And that's going to be our phosphate. If you adjust the unit cell, so this would be the unit cell, and then we can add onto this, and we can kind of see how the each unit cell will be connecting to one another. And that's essentially how this crystal is going to be growing. If we add on some more, you can see how this keeps getting bigger and bigger. And that's essentially how it's going to be growing out for this mineral. Ultimately, this is how you get the morphology that you see in the lazulite crystal. So you have this kind of general shape that we were looking at before, and in this one you can see some twinning where this shape is growing out in two different directions and they're kind of connected to each other. And that's really how we ultimately get these larger crystal shapes from a molecular viewpoint. This is a thin section of lazulite, and essentially what this is just you take a really thin sheet of the mineral and you're able to shine a bunch of light through it and then look at it through a microscope, and then this way you're able to see the really small crystals that are in this section of rock and see all the little minerals. Now if you take this on a microscope and spin it, as in this video here, you'll be able to see something that's pretty significant. So as you can see here, that blue piece is starting to change color, and in mineralogy we call this pleochroism. And this is significant because if you see this change color, not all minerals do that, and some minerals do, so this is kind of a distinguishing factor for if you're trying to classify whether this is lazulite. So just to summarize, this video went over the properties, the location, the uses, the morphology, and the occurrences of lazulite. A lot of this information came from mindat.org, so feel free to go to this website. Also, I'll be putting the links for all of the websites and sources I used in the description of this video, so feel free to check all those out if you want additional information. Thanks for watching.